In this series of videos, we're going to talk in more detail about how derivatives affect the shape of a graph. We're going to go back to what we talked about some time ago, which was given a function, what does the derivative of that function look like as a function? And a way we can do this is thinking of, again, the tangent lines at every point and thinking about what values do the slopes of these tangent lines all seem to have. Imagining a bunch of little tangent lines and as we've mentioned before, it's very helpful to notice where the derivative is 0. So there's one place, here's another place, and here's another place. Okay. Let's think about places where the derivative is negative, which means we're going to be looking for places on the graph where the slope of the tangent line is negative. So I'm going to look at each of these tangent lines and think, which ones of these have negative slopes? And what I'll notice is that this one here, all of these tangent lines will have negative slopes. And over here, there's some more negative slope tangent lines. And then over here, we'll see that there are positive slope tangent lines, and in this region as well. So we notice over here is f prime of x is negative, and same in this region, f prime of x is negative. And over here, f prime of x is positive, and same here, f prime of x is positive. We're going to use that information to figure out what we can about the graph of a function. Here's an example. They're asking you to sketch a continuous function given the conditions on the entire real line. The interval from negative infinity to infinity is the set of all real numbers. All right, so continuous function is really important. Remember what continuous means informally speaking. It means the function is defined everywhere and you can draw the whole thing without picking up your pen, pencil, marker, chalk, whatever you're working with. All right, so here's the conditions. F prime of x is greater than 0 on this set of numbers. So it looks like 0, 4, and 6 are important numbers. I should probably reflect that here in some way. The next condition is that f prime is negative on the interval 0, 4. So think back to the previous image on the previous page. F prime being less than 0 meant that the tangent lines all had negative slopes. And then in the first bullet point, f prime greater than 0 means the slopes of the tangent lines are all positive. F prime of 0 is undefined. So we have to remind ourselves, what could that look like? Let's take a moment to sketch possibilities. F prime of 0 is undefined means we have some kind of corner, some place where there's no derivative. There's other versions of the derivative not being defined, but remember, this is a continuous function, so I have to still make sure what I draw is continuous. And then the last condition here is that f prime of 4 and f prime of 6 are both equal to 0. So I'm going to start by marking my important points. Let's see. Here's 4, and here's 6, and 0 is at the origin. Okay, well, let's see, where do we want to start? I think we want to start at these points here. F prime of 4 and f prime of 6 is 0. Okay, we know that there's going to be a horizontal tangent line at each of those points, which tells us that we're going to have something like either this or this at x equals 4 and x equals 6, right? Because we have, these are the two situations in which we have a horizontal tangent line. Back to the first condition, we know that f prime of x has to be greater than 0 from negative infinity to 0. That means the function is doing something like this. It's always increasing. We're always having positive slope tangent lines in this whole region from negative infinity to 0. I know that f prime of 0 is undefined, so given what I just drew here, I will have to make a corner in some way. It's gonna have to be a corner. I can't make it something nice and smooth like one of these when I continue from 0. So let's see. What's happening between 0 and 4? Well, between 0 and 4, the derivative is going to be negative. And what that meant was the slopes of the tangent lines will all be negative. And I have to remember to make a corner at x equals 0, so something that looks like one of these. The way I have it, it looks like I'm going to be drawing something like this. Let's see what that'll look like. That's what's going to happen between 0 and 4. And remember that the derivative is negative between 0 and 4. And that's consistent with what I've drawn. We now need to account for the fact that f prime of 4 is equal to 0, which means it'll be this second option here. The conditions say f prime of x is positive between 4 and 6, which means the slopes of the tangent lines are all positive. In other words, the function's increasing. But it's also increasing from 6 to infinity, and f prime of 6 has to equal 0. So I'm not sure how that's going to look because I have to keep increasing. My tangent line slopes have to all be positive because the derivative is positive. And I have to also somehow account for the fact that f prime of 6 has to equal 0, but I don't see either of these happening here. What that tells me is maybe I made the wrong choice for how I just drew things around 6. And maybe there's another possibility for f prime of something to equal 0. Maybe these aren't the only two possibilities. So consider this other possibility, which is that. What you'll notice is there's a point where the slope is 0 of the tangent line. Looks like I'm going to have to use this version at 6. In order to keep increasing, in order to keep all the derivatives positive, I'm going to have to do something like that here. So let's make that adjustment. Okay. So now f prime of 6 is equal to 0. And that was this picture. F prime of 4 is equal to 0. That's the valley picture. The derivatives on the intervals 4, 6, and 6, infinity are all positive. Remember, the derivatives, the slopes, we interpret them from left to right. So these tangent lines, when we read it from left to right, they're going to have positive slopes.